Welcome to Erid Online Academy, Igcse Chemistry Topical Questions and Simplified Solution. We are presently on topic 5, Electricity and Chemistry, and this is volume 1 of this topic, containing a burst of 5 questions for us to consider. I want to encourage you to subscribe to my YouTube channel and also visit my website www.eridonlineacademy.weebly.com so that you can have access to more videos that will help you to excel in your academics. Let's go straight to question 1. The diagram shows an electrical cable. Which statement about the substances used is correct? If you look at this question, you need to cast your mind back to the uses of metal. Advise that you always give objective questions basically, and all your questions a topical sense, so that if you have the topic in mind, then you'll be able to answer the question in context, which is very important, which is very key. So cast your mind back to the uses of metals. You should remember that the properties of metals determine the uses to which the metals are put to. So in this case, we have electrical conductivities, electrical wirings. So yes, metals are conductors of electricity, but different metals have different electrical conductivity capacity, and considering other properties like rusting, ability to withstand corrosion, resistant to corrosion, and all that will determine the kind of metal that is used in making electrical wiring. So let's look at the options. A, the coating is plastic because it conducts electricity. The coating here, which is plastic, couldn't have been used to coat this metal core because it conducts electricity. The plastic is used here because it's what? An insulator. The plastic is basically an insulator, so it couldn't have been used to conduct electricity. So obviously this property of plastic with the use to which it was linked is obviously wrong. Okay, option B, the core is copper because it conducts electricity. Well, that sounds right. Copper is a good conductor of electricity. Okay, let's look at option C. The core is copper because it is cheap and strong. While copper is strong, it's absolutely not cheap. So C is a wrong answer. Then let's consider D so that we can choose the most appropriate options. The core is iron because it is cheap and strong. Well, iron is strong, but it may not be cheap really. But why is iron not used for electrical wiring? It can conduct electricity, but for other properties, iron can rust. Okay, so iron can corrode. So because it corrodes, it will not be a good material for electrical wiring. But copper, okay, is resistant to corrosion, so that makes it a good option for electrical wiring. So basically the correct answer here is B. B is correct answer. Let's move on to next question, question 2. Now look at this question. When substance X is electrolyzed, the amount of gases P and Q formed is shown. So this is an electrolytic cell. That's an electrolytic cell. You can see there an electrolytic cell, and you see here that's electrolytic cell. Okay, now what is substance X? What is substance X? So you just need to cast your mind back to electrolysis. So basically you need to be able to define a few terms here. You need to be able to define a few terms. What is an electrolyte? Electrolyte, very key. Electrolyte, of course, you know, electrolysis is the decomposition of substances by the passage of electricity, and the substance itself, you know, remains changed. Okay, it's changed, it's decomposed. So electrolyte. Then of course you have electrodes. Your electrodes could either be your anode or your cathode. Okay, so I want to ask you, which one is the positive electrode and which one is the negative electrode? Your cathode is a negative electrode, while your anode is a positive what? Positive electrode. Okay, so just a very quick thing here, the basic principle for electrolysis. You know that your positive ions migrate towards the negative electrode, while your negative ion will migrate towards the positive electrode. So let's consider the various electrolytes that we have here. So look at the first electrolyte, A, concentrated aqueous sodium chloride. Concentrated aqueous sodium chloride. Your sodium chloride, whenever it dissociates into the positive and the negative ion, that is your sodium ion and the chloride ion. Don't forget your state symbol, they are aqueous. Okay, now because it is an aqueous solution, you will also, that tells us that water is also present, and of course water will dissociate into its ions too. Water will dissociate into hydrogen ion and your hydroxide ion. So looking at these electrolyses, you have two ions that are positive ions, and of course you have two ions that are what? That are negative ions. So why the two positive ions migrate towards the cathode, the two negative ions will migrate towards the anode, because unlike charges attract while like charges repel. Okay, now the next thing you need to consider, when they migrate towards the electrode, what's going to happen at the electrode? When they migrate towards the electrode, what is going to happen at the electrode? So at the electrode, let's take cathode as our first electrode. At the cathode, which is the negative electrode, both sodium ion and hydrogen ion will migrate there, but one of the ions will be discharged. And in this case, the ion that will be discharged is hydrogen, because hydrogen is lower in the reactivity series. Sodium is higher in the reactivity series, hydrogen is lower in the reactivity series. So hydrogen will be preferentially discharged, meaning that hydrogen, when it gets to the cathode, it goes to the cathode to receive electron, because at the cathode you have reduction, and reduction is the gain of electron. So you have hydrogen ion goes to the cathode to receive 2 electrons to become hydrogen molecule. Okay, and your gas will be what? Will be discharged. So we can see here, if hydrogen is discharged at the electrode, definitely at P, hydrogen will be formed at P. So hydrogen will be formed here. So we can say that P, okay, will be hydrogen gas. Now let's look at the anode. What happens at the anode, which is the positive electrode, you have your anions migrating to the anodes. The anions migrates to the anode. Okay, we have said that you have two ions migrating to the anode, which is your chloride ion and the hydroxide ion. I'm still explaining the electrolysis of concentrated sodium chloride. Now when they get to the anode, ideally hydroxide should have been discharged here because it's lower than chlorine in the reactivity series. Hydroxide is lower than chlorine in the reactivity series, but because we have here concentrated, that means we have more of chlorine than what? Than hydroxide. So that gives concentration, gives chloride an advantage. Concentration gives chloride, okay, discharge advantage. So chloride will be discharged as chlorine at the what? At the anode. And that's pretty simple. So it means that when chloride gets to the anode, 2 chloride gets to the anode, is going to lose 2 electrons to form chlorine gas. So chlorine gas will be released at the what? At the anode. Okay, but in this case, if chlorine gas was actually released at the anode, then the level, the volume of gas P and volume of gas Q should have been the same, but in this case it is not. Okay, I want to repeat that. The volume of gas P and the volume of gas Q should have been the same, but unfortunately you can see here the volume of gas Q is lower than the volume of gas P. So what could have been responsible for that? Because if you look at the electrolysis of the discharge of hydrogen, okay, when hydrogen was discharged, you have 2 electrons, okay, being gained, and when chlorine was discharged, you have 2 electrons being lost. So if the gain and the loss of electrons are equal, that means for both of them it requires the same quantity of electricity. So since they are both univalent, they will consume the same quantity of electricity to discharge the gases. So if the same quantity of electricity is used and they are both univalent, then they will produce the same volume of the gas. So that tells us that Q couldn't have been chloride. Q couldn't have been chloride. So A is the wrong option. Now let's consider another option: concentrated hydrochloric acid. Concentrated hydrochloric acid. Concentrated hydrochloric acid. Now, if hydrochloric acid is discharged, you have hydrochloric acid will be broken down into hydrogen and chloride ion. And since it's concentrated, it means it's also aqueous. It's not molten, it's aqueous. So if it's aqueous, you also have hydrogen ion from water, and of course you have hydroxide ion from water too. So at the anode, only one gas could have been discharged, and that is what? That is hydrogen that will discharge us. So P, we are still getting the same thing, that P is what? Is hydrogen. But for Q here, since it's concentrated hydrochloric acid, chloride will have a concentration advantage, and so it will be discharged in preference to what? To hydroxide ion. So, and we have established in the first place that if Q equals to chlorine gas, then for this to hold, then the volume of P and Q should be the same. But in this case, unfortunately, that is not what we see. P is more than what? Q. So definitely Q couldn't have been chloride. So A is wrong and B is wrong. So let's look at the electrolysis of the next one, which is dilute sulfuric acid. Dilute sulfuric acid. Now it's getting interesting. Dilute sulfuric acid, when it is electrolyzed, it breaks down into, don't forget, dilute, that means the solution, it's aqueous, breaks down into two hydrogen ion and sulfate ion. So in this case too, because it's aqueous, you have hydrogen ion from water and hydroxide ion from water. Okay, so just as we done before, it's only one gas that could have been produced here, because hydrogen no competition, it's hydrogen that will be discharged. So we are arriving at the fact that P is hydrogen gas. P is hydrogen gas. So if P is hydrogen gas, then let's move on to the anode. Okay, P is hydrogen gas. So at the anode, what is going to happen there? You have these two gases migrating towards the anode. So which one will preferentially discharge? In this case, sulfate is far higher than hydroxide in the reactivity series. I take that again. Sulfate is far higher than hydroxide in the reactivity series. So you would expect that sulfate will not be discharged, but hydroxide will be discharged in preference to sulfate. So if hydroxide is discharged, basically hydroxide goes there or gets discharged, it's going to lose one electron to form OH, but this is not basically a compound that can exist on its own. So you have water and oxygen that will be discharged, and to be able to form water and oxygen, we're going to be needing 4 hydroxide ion to lose 4 electrons to produce 2 water and 1 oxygen. You need to be conversant with this equation for the discharge of oxygen when hydroxide is discharged in preference to sulfate or any other anion or radical that is higher than hydroxide in the reactivity series. So we are getting there. Now if hydrogen is produced here at P and oxygen is produced at Q, could that be a reason why the volume of the gases are different? Okay, that's pretty simple. Now if you cast your mind back to the discharge of hydrogen, to discharge hydrogen it requires 2 electrons. That's the gain of 2 electrons. But to discharge 1 mole or molecule of oxygen, in this case we use what? We use 4 electrons. 4 electrons. That tells us that it takes twice as much energy to produce the same volume of hydrogen to produce the same volume of oxygen than while producing hydrogen. So if we use the same quantity of electricity to discharge hydrogen and oxygen, that means if you produce 1 of hydrogen, you're going to produce half of oxygen. You can see the requirement. Oxygen, the requirement for producing oxygen doubles that of what? That of hydrogen. The requirement doubles that of hydrogen. So definitely that explains why you have more of hydrogen formed here and less of what? Oxygen. In fact, almost half of oxygen. So this is looking like a correct response. But let's consider the last one, like I always say, so that we can choose the most appropriate option. So D, molten lead bromide. D, molten lead bromide. Now molten lead bromide just consists of 2 ions, lead ion and bromide ion. Lead ion and what? And bromide ion. Okay, let me do that very well and create a bigger space so that you can understand. Okay, so now at the cathode, which is the negative electrode, you have lead going there to be discharged. So lead will be discharged, and it's a metal. So when it is discharged as a metal and the metal is discharged, it's definitely going to get attached to this electrode. It won't form a gas. Okay, so just only that shows that this option is what? Is a wrong option. Okay, A is wrong, B is wrong, but C is the correct word. The correct answer is C. Okay, let's move on to the next question. The next question, still on electrochemistry. What are the products at the electrodes when dilute sulfuric acid is electrolyzed with inert electrodes? So here it's very important for you to understand what the word inert electrode means. To be an inert electrode, that simply means that the electrode is made up of unreactive, substances, elements like carbon, okay, platinum. That is talking about unreactive metal, okay, least reactive metal, if you like, platinum. Okay, these two just common example of electrodes that are inert. Okay, now sulfuric acid is electrolyzed, just as we looked in the previous question. Sulfuric acid is electrolyzed, so you have hydrogen and what, and sulfate ion. Okay, since it's dilute, definitely it means water is there. Water itself will be broken down into its various ion. Okay, water and hydroxide ion. So here at the cathode, don't forget the cathode is the negative electrode, while the anode is the positive electrode. Cathode is negative electrode, anode is the positive electrode. So definitely hydrogen migrates here and it's discharged as what? As hydrogen ion will migrate to the cathode and is discharged as hydrogen gas. That's pretty simple. Get used to writing your half equation. It gains 2 electrons and is going to form hydrogen gas. So let's look at the option for your cathode. Your cathode here, A says hydrogen and oxygen. Oxygen can be formed at the cathode because it means that hydroxide would have migrated to the negative electrode. That's wrong. Okay, so all the options that do not have hydrogen at the cathode, definitely obviously wrong. So by elimination you can remove those ones. They are what? They are wrong. So you are left with options that have hydrogen at the anode, at the cathode rather. So the first one, which is B, says oxygen and what? And hydrogen. Sulfur dioxide, which is D, and what? And hydrogen. So basically, looking at these, sulfur dioxide couldn't have been discharged at the what? At the anode. So what could basically discharge at the anode? Here you have 2 ions migrating to the anode. 2 ions migrating to the anode. You have your hydroxide and what? And your sulfate. So basically now you should know that hydroxide will be discharged in preference to sulfate because hydroxide is lower in the reactivity than what? Than sulfate. So if your hydroxide is discharged, like I said earlier, that means you have 4 hydroxide, okay, losing 4 electrons to give you 2 water and 1 word oxygen. If you look at the equation, it's absolutely balanced. So oxygen is produced at the what? At the anode. So your correct response is what? Is B. Correct response is B. So question 4. Question 4. Electricity is passed separately through concentrated hydrochloric acid, concentrated aqueous sodium chloride, and dilute sulfuric acid. So in solving this this particular question should be easier now because we consider various electrolysis. When concentrated sulfuric concentrated hydrochloric acid, it's discharged at the cathode, which is a negative electrode. Yes, you have hydrogen migrating to the negative electrode because hydrogen is positively charged, so you should know that it goes to the cathode. So if it gets to the cathode, it's going to gain electron. So if we have 2 hydrogen, it's going to gain 2 electrons to form what? To be discharged as this. Okay, but at the anode here, chloride will be discharged truly because it is concentrated what? Hydrochloric acid. Anytime you have a concentrated solution of chloride, halide being electrolyzed, if it is concentrated, then halogen will be discharged at the anode. I take that again. When you have concentrated halide being discharged, concentrated halide, okay, being electrolyzed, concentrated halide being electrolyzed, then your halogen will be discharged. Halogen will be discharged. That's pretty much a clue. Halogen will be discharged. So in this case, 1 looks correct. Now let's take a look at B. 2. Concentrated aqueous sodium chloride. Concentrated aqueous sodium chloride. So if you take the anode, because it's concentrated sodium chloride, yes, chlorine will be discharged. That's correct. But at the cathode, concentrated sodium chloride, you have both sodium ion and hydrogen migrating to the negative electrode because they are positively charged. But when they get to the negative electrode, which one will be preferentially discharged? There is going to be competition between the ions now. But if you look at your reactivity series, sodium is far higher at the top while hydrogen is below. So you would expect that hydrogen will be discharged in preference towards sodium. But the option here is telling us that the cathode, the product is sodium. That is not correct. That is not correct. So 2 is wrong. Then number 3, dilute sulfuric acid. Hydrogen product at the cathode, which is correct. Okay, refer to question 3 and question 2. Okay, hydrogen will discharge, which is correct. Basically, H2SO4, when it's discharged, it's going to form this ion. Okay, basically, and since it is concentrated aqueous, so it means that the only ions we have at the cathode are just hydrogen ions, so no competition. So obviously hydrogen will be discharged at the what? At the cathode. But at the anode, you have competition at the anode, and the competition at the anode is between sulfate and what? And hydroxide. Sulfate and hydroxide. So which is higher in the reactivity series? Sulfate is higher in the reactivity series. So this guy, hydroxide, will be discharged in preference to what? To sulfate. And when hydroxide is discharged, that means, don't forget, 4 hydroxide losing 4 electrons, it produces 2 molecules, 2 moles of water and 1 mole of what? Of oxygen. So oxygen is discharged here at the anode, while hydrogen is discharged at the cathode. So 3 is correct, 1 is correct. So your correct answer here is what? Is 1 and 3 only. 1 and 3 only. So let's look at the last question for this volume. The last question for this volume. I hope you have been enjoying this explanation. Which role describes the electrolysis of molten bromine? This should be very simple to tackle. So potassium bromide, okay, molten, that means they use heat energy to melt it into potassium, into the liquid form. So you have in the liquid form, you have, which is an ionic compound, you have potassium and what? And bromide ion. So definitely by now you should know that your positive ion migrate towards the what? Towards the negative electrode. Your cathode is a negative electrode, while your negative ion will what? Migrate towards the what? Positive electrode. Anode is the positive electrode. Anode is the positive electrode. So basically potassium, okay, when it gets to the cathode, what's going to happen to potassium at the cathode? It's going to what? It's going to gain electron. Potassium is going to gain an electron, because at the cathode what you have is the gain of what? Of electron. I'll give you mnemonics to help you recall that basically. So you have potassium being discharged, then bromide, okay, when bromide gets to the anode, it's going to lose an electron per bromide atom. So if you have two bromine, two electrons will be lost, so that we can form a diatomic bromine molecule. So basically we have potassium and what? And bromine. So bromine is formed at the anode. Bromine is formed at the anode, while potassium is formed at the what? At the cathode. Okay, so the correct answer here is what? Is B. B is the correct answer. So your mnemonics for recalling what happens at the cathode and the anode is basically simple. You can use CRAO. CRAO simply means at the cathode you have reduction. At the cathode you have reduction, while at the anode you have what? Oxidation. Let me take that again. Use CRAO. CRAO. At the cathode you have reduction, while at the anode you have what? You have oxidation. I'm pretty sure this run through the 5 questions have been helpful. Till I come your way once again, I'm Larry Ogutoye. Remember to subscribe to my channel. I am your professor. See you in volume 2.